Okay, so now we have spent quite a bit of time learning about how to measure matter, different parts of matter, looking at volume, mass, and density. And we are now going to move into actually talking about what matter is all about. Everything in the universe, aside from light and energy, is matter. As we know, matter is anything that has mass and takes up space. So we're going to talk about what all those ideas mean and what the particles of matter are. So the first thing I want to make sure you have in front of you is the notes. So you have 3 pages that you could print out from the Nomia site that were also handed to you in class. These would be the first 2 sheets describing matter notes, and you'll be completing these as we go along through this lecture. And then the 3rd page is about particles of matter, and that's just a single page. And we're going to just complete this as we go through. So the first thing that you'll see on your describing matter notes page is a flow chart, and what we're going to do is fill this in. So at the very top you'll see we have matter. So if you want to write that in that top circle there. And matter is classified as either a pure substance or as a mixture. So if you can go ahead and write those in there. And let's start first talking about pure substances. So a pure substance, and if you look underneath the flow chart on your page down in this area, you will see that there's a blank space, a line, and then after that the word substance. So go ahead and write pure on that line. And then you'll write these notes made up of only one kind of matter. Notice that one kind is in red. That's what you're going to write in that first bullet underneath where you wrote pure substance. It's made of only one kind of matter. A pure substance also has definite chemical composition. That means that the chemical composition of a substance, of a pure substance, will never change. And it also has its own definite properties, things like its melting point, boiling point, etc. So those are 3 little bullet points that I just want you to go ahead and write. Make sure you have the words that are written in red underneath the pure substance. I'm going to go ahead and erase these marks so we don't get ourselves confused. Okay, so pure substance is made of only one kind of matter, has definite chemical composition, and has its own definite properties. Okay, so now we're going to talk about specifically elements. So if you turn your notes page over to page 2, the first thing you're going to write down in that big space there is the word elements. So elements are pure substances that cannot be broken down. Pure substances that cannot be broken down. So you're writing down cannot be broken down on your notes. They can't be broken down into other substances by either physical or chemical means. So these basically mean all of our elements that you've heard of in the past, I'm sure. Hydrogen and oxygen. Sodium is another one, chlorine, any of the 100 plus elements that we know of in the universe at this point. Let me erase this. Okay, now let's talk about the other type of pure substance, in addition to elements, are compounds. So underneath where you wrote about elements in those lists of hydrogen, oxygen, sodium, and chlorine, go ahead and write the word compounds on that blank space. So compounds are pure substances, and they are made up of 2 or more elements that are chemically combined. Okay, so 2 or more elements chemically combined. Those combined elements actually lose their individual properties when they combine. So for instance, if you look at these examples, water, you'll see the symbol for hydrogen, and you'll see the symbol for oxygen. Now, if you take hydrogen and oxygen by themselves, obviously they're gases. But what happens when they chemically combine? They actually create water. Okay, same thing with NaCl. So NaCl is the chemical term for sodium chloride, which is what we use as table salt. Sodium is actually a metal, and chlorine is a gas. When they combine and they make sodium chloride, it's a very, very different substance than if sodium and chlorine were all on their own. So when these elements combine chemically, they lose the individual properties that they brought to the so-called table and form a completely different substance. All right, let's erase this. And we'll move on to a mixture. So underneath where you wrote about compounds, now we're going to write about mixtures. So go ahead and write mixture on that line. Okay. Mixtures are two or more pure substances that are in the same place, but they're not chemically combined. They're physically combined. Those individual substances, they keep their individual properties, and they can usually be easily separated. Sometimes it takes a little bit more of a trick to get them separated, but for the most part, they can be easily separated. The best mix of all mixtures are called solutions. And that's when you see things like cranberry juice or milk. Those are they're the best mixed of all, and you can't really separate them or see the individual components too easily with your bare eye. Another example of a mixture is air. So we may breathe oxygen, but there's also a lot of other things in the air. There's different types of pollutants. We've also got some nitrogen in there. So the air is also a mixture that we are very familiar with. So if you just take a quick look at that flow chart and make sure you have all of those pieces filled in. Sorry. Make sure you have matter at the top, pure substance, and mixture as the two ways that you can classify matter. And then underneath pure substance we have elements and compounds, and then underneath solution, mixture, we have solution. Okay. So let's move on. So here's an example of a solution. So right where you were talking about mixtures, there's another flow chart of salt water. So a great example of a solution is salt water. So salt water is a mixture. It's made up of NaCl, otherwise known as salt, and of H2O, otherwise known as water. So salt and water. So then if you take a look underneath sodium chloride, again, sodium chloride is made up of two elements, sodium and chlorine. And then under water, we have hydrogen and oxygen. So a solution, you'll see, obviously, we have two different pure substances that have combined together, and those pure substances or compounds are made up of individual elements. We can go ahead and label that as follows. So underneath, over on the side where you see sodium chloride, NaCl, you can go ahead and write sodium chloride in that circle, and then next to it on those two lines you have pure substance and a compound. Okay, so you can go ahead and write those on the lines just to the right of where you see the salt. Underneath the sodium there are two lines. You can write the word pure substance on the first line and then the word element on the bottom. And chlorine is exactly the same. Chlorine also is a pure substance and it is an element. Now similarly over with water, we have a similar situation. Again, water is a compound, also a pure substance. You can write those words onto the lines that are next to the word water. And then underneath hydrogen, that's a pure substance. Go ahead and write that down. And it's an element. Same thing with oxygen. Pure substance and an element. So, so salt water is a solution made up of pure substances all across the board, whether they be compounds, and then you can break them down further into levels of elements. Okay. So now let's talk about the actual particles. We talked about pure substance and elements, but what about the actual structure? So it turns out that an atom is the smallest particle of an element, and you can write that down on your sheet that says particles of matter. Again, the words are in red for you to write down. So atom is the smallest particle of an element. You'll see in your diagram on your sheet, here's some atoms of the same element, and you can tell that just because they're the same size and they're in the same colors. So we'll just call this the element green. So notice everything is green. Sometimes you can have atoms of different elements in a sample. So in this case we have orange elements and we have green elements. So it's kind of a mixture of different elements. Then underneath where you see those diagrams, you can go ahead and write the word molecule. So molecules are cool. Molecules are a group of atoms. They can be of the same element or they can be of different elements. And they are joined together and act as a single unit. So here is a diagram of molecules of the same element. So in this example, they're all purple. Notice that there are two atoms that are combined. They're paired up. They are chemically combined. They're not moving away from each other. They cannot be broken apart by any physical means. So they are together. And then sometimes we have molecules of different elements or of a compound. So in this case, we have two pink atoms and one green atom. To me, this looks like it could actually be a water molecule. And they're all the same. If you look in the sample, they're all the same type of compound. So these are molecules that are made up of different elements and they have formed compounds. What holds those atoms together is something called a chemical bond. So what you could do is write chemical bond right after we wrote about the molecule. The chemical bond is a force that holds those two atoms together. And you can tell because they are fused together. They're not apart like they are over here. You don't see any space between these. So now you know you're dealing with a chemical bond. So let me go ahead and erase everything on that. If you look here, this is a nice kind of visual. Just don't get overwhelmed by it. It's just kind of a snapshot of all the different types of diagrams that you can look at when you're thinking about describing the particles that are in a sample. So on the top line here we have elements. Here we have atoms of a single element. Okay, we can call this the element green. And then we've got molecules. Remember, molecules being two atoms that are joined together chemically. Here we have mixtures. So notice we've got a sample here with green and orange. So these can be representing different elements, more than one element in the sample. Here we've got individual atoms of the green, plus we've got a molecule of purple. So we could say here, because these are let's see, that the purple molecules are representing the the compound purple. These can be called elements. They can also be, over here we can look at this as if it's the element green. So this would we have a mixture of two different elements. Same thing here. We have a molecule of purple element and we've got a molecule of pink element. So now we've got, again, a mixture of two different elements. And here we've got a molecule of a compound, again, because there's two different colors represented in that fused unit. It's acting as its own unit. But then here too we've got just the pink element. So now we've got a mixture of compounds and elements. And then finally here we have just plain compounds because all of these units in the sample are the same. So it's one kind of compound. And we'll be going over this more in class. This can be a little confusing. So in a nutshell, if we look at how we can describe matter, it is a pure substance or a mixture. Pure substances are classified as elements or compounds. And here we have a visual of what an element could look like. Again, a single sphere, an atom of a single type of element. And here is a compound. Again, they're all kind of, they're all fused together and they all look the same. There's two red and a gray, two red and a gray, two red and a gray. So they're all the same compound. With a mixture or a solution, we can have, what you do is you look to see if there are differences in the types of unit that are within the sample. So indeed here we've got an atom of an orange element And we've got a molecule of the green element.